All right, so thanks for coming out. Like Brian said, happy to have you guys. Happy to talk about something I've been working on. A few of us in Columbus have been working on for 2+ years now, in some capacity or another. So a little bit about me. I am a developer here in Columbus. I've been working with Elixir for roughly 2.5 years professionally, and a little bit before that unprofessionally, as I like to say. You can find me if you want to find me. Reach out after this talk. I'm Go Fix Your Data on Twitter. I'm J Denen on GitHub, and I'm just Johnson on both the Columbus Slack and the general Elixir Slack. So feel free to reach out at any point. I am a huge Emacs fan. I never miss an opportunity to tell people and spread the gospel of Emacs. So if you're a Vim user, please keep that to yourself. I don't care. But if you're an Emacs user, awesome. Keep that up. But we're not here to talk about Emacs, which is unfortunate, but we're not. I am lucky enough to have been working with Elixir professionally for 2 years, but beyond that, it's been open source Elixir. I've written very little Elixir code that is closed source. A lot of that has to do with Smart Columbus, which was something I will touch on here in a minute. But it's a wonderful ecosystem that we all work in and enjoy working in, and it's great to give back and to get paid to give back, which is awesome. So, like I said, Smart Columbus is part of this story. This is not the story of Smart Columbus, though. So this is just for background. But in 2016, the city of Columbus won the US DOT Smart City Challenge. It was a big deal for us in the Central Ohio community. It was a $40 million grant handed out by the federal government to become America's first official smart city. We, being a Midwestern city of medium size, beat a whole bunch of juggernauts who you'd expect to win this award. The Denvers, the Austins, the San Franciscos of the world. We beat them all, and we got that money. And we started about a whole bunch of projects in the city. 9 use case projects to be exact. They range from helping expectant mothers make it to prenatal trip or prenatal care appointments, to connected vehicle environments and the effect and measuring of technology and how it can improve the city. One of those projects was the Smart Columbus operating system, which is this foundational data layer of Smart Columbus as a whole, of the entire program. The city described it as the heartbeat of the whole shebang. And what it is a data platform, more or less, that pulls in data from all around the city for all of those projects. And it acts as an open data portal as well to make it available to the community. But its key function is serving those 8 other projects. It was a really interesting challenge, this operating system. The thing about cities is, like, nothing is the same. Inside the city of Columbus, this data platform that we had to build had to handle any format. It had to handle any source of data over any communication protocol, basically. It had to solve for the 8 problems that Columbus was trying to solve for. But because this is a federally funded grant project, the government wanted it to work for any city in the United States. So a city as big as LA or a city as small as Dayton, Ohio, should be able to pick up and run with this data platform and use it to make their city better and improve lives of their citizens through technology. It also involved data of just all kinds. Like that, I cannot express that enough. We're dealing with manually entered data into spreadsheets from 3 years ago, all the way up to, DSRC connected vehicle to connected infrastructure type data. We have to handle all of it. Data that is one-time batch only, and data that is pushed, once a second for eternity. And the challenge of that is difficult, to understate it a bit. Like, how do you account for just the wide variety of data? To make matters worse, that in some cases lives are on the line when it comes to data. Maybe not directly, but in how you can perform or make people's lives better, or get ambulances to them quicker, things like that. So just to reiterate, broad scope, broad consequence, very wide requirements as far as nothing too specific. You never know what's coming in a city. Basically, a developer's nightmare is what I'm getting at. The requirements are not there, and you have real ramifications of screwing it up. But we built it. I'm just going to skip to the end. We built it. We did a pretty good job. We built it to be open source. So like I said, the government wants any company or any city to be able to use it. So we open sourced the whole thing, made it available to all the cities. We put it in Kubernetes as a way to abstract away from the cloud. So AWS gave Columbus 1 million credits to work with as part of this grant. But that doesn't mean, the next city isn't going to be on Azure or the next city on Google Cloud or on-prem even. And then we chose Elixir as the language that we were going to build this thing in. We felt like the functional aspects of a data platform make a lot of sense, data in, data out. But then Elixir and the Erlang ecosystem and its resiliency really fit this like data utility that we were trying to build. Beyond that, I will say that we didn't start here. We did try to go your more traditional Hadoop route to stand up via Cloudbreak a Hadoop instance and use Spark jobs to process all the data. As Jeff and Brian can attest, that was a nightmare. Hadoop is a nightmare. If you disagree, we can get in arguments about that later, but my personal take is it's awful. So we rolled our own from scratch, like I said. We did utilize some open source aspects. We use PrestoDB as one of the things. We use Kafka. There's a lot going on in the platform. But I don't want to just blow smoke up you guys and say like we did it perfectly. We built this thing with some shortcomings, right? There are definitely some places where we didn't get up to where we'd like to be. We got locked into the grant, right? The grant has very specific aspects to solving Columbus problems, and we focused on those a lot, and we let those dictate a lot of the requirements, a lot of the features of the platform. We also, we focused on immediate needs. We're developers. We had deadlines, and we wanted to meet them, and we cut corners when we had to and where it made sense. And ultimately, what we built ended up feeling a little bit too rigid. It certainly works for Columbus, and it's still in production for Columbus and working fine. But it's not flexible enough to meet any city's needs. And beyond, like, we really like this thing that we built, and we'd like to take it to companies as well. There's no reason, it's Apache 2 license. There's no reason anyone couldn't pick up and use it. You don't have to be a city, right? And so we built this thing, but we built it again. We restarted from scratch. It's still open source. It's still Apache 2 licensed. But we felt like there was just an opportunity to start over with all the things that we've learned along the way, to question every assumption that we ever made while we built this thing in the first place. And we got the big stuff correct. I'll argue that, and I will give Smart Columbus credit there. Is the big things that really matter we got correct. Kubernetes was the correct choice for our constraints. Kafka made a ton of sense, and it still does. PrestoDB is a fantastic piece of software that, if you're unfamiliar with it, check it out. But the little things we got wrong along the way, or not wrong, but they could be better. We wanted to focus on internal flexibility, and we wanted the platform to learn and grow, and learn and grow past the point of what the U.S. federal grant will allow. So I'm going to walk you through 3 things. The overall concept that we were trying to accomplish, our initial approach, the problems that we saw with that initial approach, and then the lesson learned from those problems, and how we addressed them again. So I should say there is a second platform, as I've alluded to. It's called Hindsight. We kept talking about, hey, in this thing, in hindsight, we would change this. In hindsight, we would change that. And ultimately, one of our coworkers was just like, name the damn thing Hindsight, so that sentence makes even more sense. And so we did. We named the new platform Hindsight. And so we're going to walk through these things. So the first big concept is the flexible architecture. This is part of meeting any city's needs. A city, big or small, has very specific use cases that they're trying to solve. In Columbus, it's transportation. In Denver, it's often air quality. In many cities, it's inequality and equity to things like transportation and legal services and whatnot. In some cities, it's food. And there's a number of use cases, right? The cities all across the country are different. They have very similar problems, but their focuses are way different. Part of the flexible architecture idea is that, okay, we'll build you a thing. We'll come with Hindsight or with the original platform, and it'll get you 60% of the way there. And it's up to you to build out the rest because that's specific to you and the problems that you're trying to solve. So the architecture needs to be plug and play to make that possible. And so that's the idea. That's the big idea, the big concept that we were going for. So our initial approach is microservices, of course. As far as I'm aware, that's the only buzzword in this presentation. I think I left blockchain out. I think. I don't know. I think. No promises. But the approach is microservices, right? This is the classic case for microservices. This is your traditional case for microservices. You want a plug and play piece of, call them bingo, nice. You want plug and play your pieces that you want and don't deploy the pieces that you don't want. It just makes sense. Sorry, I'm opening chat so I don't miss anything. That makes sense. We're gonna go with microservices. The problem with that approach is only kind of a secondary problem, but we're trying to develop a platform, right? We're not trying to develop a single entity in a vacuum where a microservice makes sense. We're trying to build a cohesive ecosystem for ingesting data, for accessing data, for transforming and whatnot of data. And that becomes a little bit of a problem in just the cohesiveness of the situation. We, at its highest, we had something like 28 repos in the open source side of things. That made local development just very difficult. Like, how do you run an entire ecosystem all together when it's spread across 28 different repos? The answer is you don't really, which leads to inconsistency just across the platform as a whole. The other piece was, this is an open source project, and we love having new people involved, which is kind of a problem in the microservices model. I got a lot of feedback from people who wanted to get involved in this community effort who said, there are 28 repos. I have no idea where to start, which is legitimate feedback. And so one of the problems with just a microservices approach. So the lesson that we took from this was umbrellas. Umbrella applications were our solution to this problem. Eventually, on the Smart Cities original platform, we took those 28 repos and we squished them all together into an umbrella, which is not a fun experience, just so we're clear. We made sure we got all the Git histories, and it was a mess for a long time as we worked those kinks out. Today, it even still feels disjointed because those microservices started as separate and had already diverged as far as consistency goes. Jeff is smirking for some reason, so he probably agrees, I hope. Jeff, you're not allowed to talk. Don't take that as a permission. So what's great about umbrellas is it still lets you be service-oriented or microservice-oriented when you need it, right? Especially with Elixir 1.9 and the ability to cut releases. What we've essentially done in Hindsight, and you can see, you're seeing part of our release setup there, is we've got the ability to produce release artifacts that are service-based, which let us put them in Docker images and deploy them into Kubernetes individually. So we still have all of that capability when we need it, which is basically when we go to production. But it can be entirely monolithic when we don't need it, which is great for local development. I can now run a cohesive platform all together on my single machine locally without having to run Minikube or some other bastardized version of Docker containers stitched together. We, in Hindsight, have an application in our umbrella that's just called Platform Runner. And all it does is, as you can see in that top little code block, is pull in the services as its dependencies. And those are basically the only dependencies. It's also how we do end-to-end testing to make end-to-end testing through the platform really easy. Those tests are written in the Platform Runner, and you just run them like any other tests. So the second concept that I'm going to talk about is composability. This really goes to addressing the any format, any source of data type of problems that we had. We need to get CSVs that were converted from XML or not XML from Excel sheets 2 years ago and have been sitting in an Access database, but we also have to accept XML that is retrieved via WebSocket and whatnot. And so composability is how we envision building, with small blocks building on top of each other until we get to the solution. Our initial approach was to use processes to do this type of stuff. What you're looking at here is some GenStage setup for how we go and retrieve data, decode it, and do some other small normalization pieces in the old platform for getting the data and working with it, pulling it into the platform. Extract in the ETL model, I suppose. It's a fine solution. It works, but it does have its problems. One, it's a little bit complicated. If you've not looked into GenStage, definitely do that. And we didn't just do GenStage. We've tried GenStatum. We've pieced together different, just like vanilla Gen servers and tasks and whatnot along the way. But they all had the same problem. And to me, that was the Openclosed principle. So if you're not familiar, I don't know how new people are programming and who are attending a remote Elixir meetup, but open for extension, closed for modification, of course. So we want to extend the behavior without changing the source code is the idea. In this model, doesn't really work. If I want to add a new behavior to the system, I probably have to change this exact file to sync another stage in GenStage. And that's beyond just like actually creating the stage itself or the consumers and producers and whatnot. So one of these that I'm going to point out too is in the old platform, you could download a file. Let's say you're just going to go get a file via an HTTP GET. You're going to download it to a local file, temporary file, so that you can read it out of there, stream it out of that file later. And then you need to do a file remove, because you want to clean up after yourself, of course. But what if you want to add Kafka as a data source? Right, so you want to connect to a third-party Kafka and start reading in data in real time. Are you going to write a file to that file system? Probably not. It doesn't really make much sense. So how are you going to handle this cleanup stage? Likely you're going to come in here and modify code, source code, not extend it. Our lesson here is use first-class functions. Elixir is a functional programming language, and I think that gets a little bit overshadowed for all of the Erlang-y process bits, and we don't always utilize the functional side as much as we should. So one of the things we set out to do with Hindsight after the fact was, okay, we're gonna pass functions around instead of coding things directly into the services and whatnot. And so you're looking at, in that same extract side of things, what we do is we have functions that we pass around that actually go and get the data. And at the end, we call, on the right side there, the run after functions function. And all that does is take a list of functions, iterate through them, and call them with the messages that they're dealing with. It makes like removing the file at the end of a HTTP GET really easy. And likewise, if you're going to connect to Kafka, well, you don't need that function, so you just don't register that function in the after functions list. It works decently well. The last concept that I'm going to talk about is simplicity. So This is kind of the whole reason we went with not Hadoop. That's kind of the big picture. We need this platform and the coming platform after it, Hindsight, to be runnable by any city in the country. Like we said, cities don't have a lot of resources to give to this type of thing. They are strapped for cash. They are strapped for talent. And so standing this up for someone who can only, one person who can only give half of their time of their day job towards babysitting some platform. Well, that's not Hadoop. So we're going to make this thing simple, as simple as we can. So again, I'm going to go back to the microservices and specifically around Elixir. Our approach there was, hey, this is going to simplify your life. The Elixir side of things is the let it crash. We're going to restart it. We're going to supervise. We're going to be smart about how we handle those things. And we're going to break down each logical chunk of code into a microservice and deploy that. And so you only have to monitor the things that matter at that time, and you'll know how these things work out. Conceptually, it's easy to reason about, and you have to do less babysitting. It's not a wrong approach. It's not a wrong line of thinking, in my opinion. But the problem becomes you get complex microservices, which is, of course, a little bit of an oxymoron, but it is almost inevitable. The microservices always start out micro, and they end up growing and growing and growing as you have, it just makes sense to add this one little bit more. So the other side of this, so as an example, I guess, this is the extraction service in Smart Cities Data. And I run a tree on its lib folder, and I get 77 lines in return. And that's one of our, let's say, microservice. We'll admit that's not a microservice, but it's a service at this point. We've got a complex service as this thing just grows and needs to do more, and we have to handle XML and JSON and GTFS and la-da-da-da-da, right? And it just continues to grow, and it gets more and more complex internally. Likewise, the code itself, beyond just the number of files, gets more complex. Here's us having to do a decode. So you go and grab CSV. How are you going to turn that CSV into manageable data within the platform? How does that compare to GeoJSON or GTFS, which is a binary protocol? There's functions to figure out all this stuff. You use some pattern matching, you use some casing, that type of stuff. It gets complex as you add more and more and more. The lesson here is protocols. Protocols are the answer. And protocols are not just the answer to this specific problem. I want to be clear, protocols are the answer to every single problem you've ever had. They will solve COVID, and Elixir protocols will be involved somehow, I am convinced, because they're always right. They're always the right way to go. This is a little bit of sarcasm, but it's a little bit not. So in hindsight, looking at the same service or same principled service of, hey, this is how we do an extract, how we go and get data. You run a tree. We had 77 lines in the old output. With protocols, we have 11 lines in the output of that tree. Now, I won't attribute all of this to protocols, but this is largely about protocols. And the code, if you're not familiar with protocols, it's about polymorphism, right? It's about your services doing more by doing less. That's kind of what we've landed on with this thing. So instead of baking the logic of a service of how to go and extract data and how to decode that data into the service itself, instead we bake that logic in with the objects that represent that data. So we have an object that represents an HTTP GET. It contains all the data of, like, this is the URL you need to have. This is the credential token that you need to have, right? And how that is executed, how that logic plays out, it sits right in with that object via a protocol. What you're looking at on this screen is the decoder protocol. So on the right, the very most right, is the actual protocol itself. It's the decoder. You got to define two functions. On the left is an implementation of that protocol for CSV. So it's pretty simple. There's just the lines or bytes is a one-line function, but and the decode, the actual doing, is a decently sized function, but not that big, and it works. And then that middle piece is the actual service itself, not the entire service, but that is our extraction service and how it does decoding. It's now one line to decode all of the decodes, all of the formats: CSV, XML, JSON, GeoJSON, JSON lines, protobuf, all those things. And protocols really made that possible. And now we probably have less microservices in the platform. Our platforms do more in the sense that they are able to handle more formats, more sources, more, they can write to more destinations, that type of deal. So they do more, but they do far less. Our services are very stupid. All of the logic sits with the data itself, and thanks to protocols, and that's what makes this super powerful.
Hey, Johnson, I'm sorry to interrupt. Can you adjust the height of this window? It's giving us a letterbox view, and it's kind of squashed.
Oh, I did not realize you were in letterbox view.
Beautiful. Thank you.
Sorry about that. Have you guys been in letterbox view this whole time?
Yeah.
Oh.
It didn't matter till now.
Okay. All right. Yeah, so that's protocols at a very, very high level. I cannot, again, emphasize enough that if you've not worked with protocols or not really looked into them, how much of a difference that they can make in your code base. If there was one thing that we would, like, if we changed nothing else in this rewrite of the Smart Columbus platform into Hindsight, we would probably just do this one thing of switching to protocols, a protocol-based solution. Let's see, is that it? Oh, that's all my notes there. All right. Questions? I will have a small wrapping up piece, but if y'all have questions, feel free to shout them out now.
Quick question. Do you guys have any particular plans for how to avoid kind of some of the architectural pitfalls that it sounds like you fell into on the first one? Because I know that's always been a peril when I get involved in a big rewrite, is everybody's like, oh, we'll just rewrite everything. And then you discover, well, actually, some of the problems that led to it being like that are still there. And they weren't code problems. They were, org problems or people problems or things like that.
So we've largely avoided that type of, you're absolutely right. A lot of our org problems in the Smart Columbus space is just the grant itself, right? The grant has a very limited time frame. There's a, we call it juice to squeeze ratio, but the balance of time versus priority versus what you get in return, right? Rate of, or return on investment. With this platform, we have less emphasis on that. We know we have more time to build it. We are taking the time to build it correctly. It is entirely open source, so there's no race to the market type things that are pushing us in a lot of ways. I'm simplifying a lot, but largely we don't have those issues because of that. As far as architectural problems, we haven't run into them yet. That's not to say that we won't. We do joke a lot that we can't wait to start working on Hindsight as the next rewrite of the platform when we learn more and grow this thing past the point of viability. Hopefully that is just a joke. Hopefully. God, I hope it's a joke. I hope that answered your question.
Absolutely. Thank you.
Cool. Anybody else?
I'd be curious, maybe you already mentioned this, but what is the new Hindsight version in production now, or what bits of this are in production, and maybe more about that?
Yeah, so we've got, with Hindsight, production is a little bit different in that we have multiple places where we're using it in some fashion. We are using it a lot internally, more than with clients at the moment. That's more of a ramification of our current client environment with COVID and whatnot than anything else. But we are building a lot of POCs internally with this and in different instances of this. Smart Columbus, obviously has their platform. We are in some conversation with them, and it is still my hope that these two things will come together again to improve Smart Columbus and how they're operating there, just efficiency-wise and code-wise. The scope of Hindsight is a little bit different than Smart Columbus in that we don't have as much of the open data focus that Smart Columbus does. So it's not like a one-for-one swap. I think those two pieces will dovetail together nicely. But we do run this in some internal form of production in multiple places, if that answers your question.
Sure, thanks.
Cool. Anyone else? I can't see you guys. This was by having this in full screen mode, I can no longer see your faces. So, although
does it make it way easier to do a presentation, not having to look at people and wonder if they're
no,
judging you?
I actually think it's way worse. I would much rather see you guys' faces so I can know, like, hey, that joke actually landed, or that joke was terrible, and I should move on very quickly. Because I can't see your face. I don't know, with my dear God Hindsight joke, I don't know if that was good or it sucked. Jeff, shut up, Jeff.
I know if it was me, my wife would be on the other side of that door just racking up jokes to, give me a hard time about as soon as I walk out the door.
Yes, yeah. Luckily, I got little ones that she's taking care of right now, so she can't judge me too hard. All right, cool. So last couple slides here. As part of building two open source data ecosystem platform things, we've had to build a lot of libraries along the way, and those have all been open source as well. So these are just a few of those things. They are out there on Hex, so feel free to check them out. Elsa is probably the big one that we like to tout a lot. It is a Kafka client that is unopinionated, unlike the many or the other few Kafka clients out there. We are a big fan of it and what we've done. The other one probably worth checking out is Devo. Devo is a really interesting thing we built. Oh, Todd knows Elsa. Sweet. Devo is a really interesting thing we built as part of Smart Cities Data, and we continue to use it on Hindsight. It's a Docker integration testing framework. So when we do stand up things like Kafka, when we stand up PrestoDB and we have to integrate with those, our integration tests use Docker Compose to stand them up, and then they are configured to work internally, so we can just run tests and actually use our edges. And it just works with like a mixed test integration, and Devo will do its thing. It will stand up your stuff, make sure they're healthy, and then run your tests, and then tear everything down. Definitely worth checking out. I won't go through all of these, but those are probably two highlights. And then, yeah, I'm done. If you want to see Hindsight itself, it is out there on GitHub. Like I said, it is in Hindsight/Hindsight on GitHub. If you are interested in the original platform, it's Smart Cities Data/Smart Cities Data. I didn't put that in text, but you guys can figure it out. Cool. Thanks for listening. Hope I didn't bore you too much.